We'll be starting pretty much officially very soon.
Let's go, guys.
We've got about a minute to go.
1 minute, get your questions in.
That's right.
I'm showing live.
If you like the tip of the day logo here, Frank actually drew this. Frank Zaragoza is the cameraman on today's live tip of the day. So he just drew this up for us in like 30 seconds before we started. Because I had to erase it. We were filming some other tip of the day and I had to erase it and use the board the other day. And so he just made this logo for it. It's pretty good. That's pretty impressive.
All right, everybody, let's go ahead and get started. Thanks for joining us today. We've got Mark Terryberry as usual. Thanks for being here, Mark. Andrew Harnett, let's get hyped. Tip of the day live. Andrew's going to be giving us all of the comments from the chat room. And as usual, let's start out with Mark today. How are you feeling, Mark?
Doing excellent. I've got my coffee. I've started the day out right, and I'm ready for some questions. And I hear the air blast there. So we have the air purge on that ST20Y, which I should have turned off. So every 5 minutes, I think we'll hear that psh noise. But beyond that, I'm doing pretty good.
All right, we've got the chat is already rolling. We've got some people saying hello, good morning, and greetings. Let's start with Andrew. Andrew, what do you have for us this morning?
Well, maybe we just start with one of the questions from the chat here. Slugs is lighting us up. It looks like one of his main questions is Haas considering doing a mill turn machine? And the answer is yes. I think we talked about this last time or the time before. Right now, it's in like the prototype stage, and the engineers are still figuring things out, basic configurations and stuff. So we're not going to give you any more information than that right now, but it is on the agenda.
Very cool.
Yeah, should be interesting. So, on your last tip of the day, your bandages tip of the day, there was a lot of comments about using super glue and how you'd forgotten that, and I don't think you'd forgotten it so much as maybe left it out for a certain reason. So that was one thing, and then we were also talking about gloves and protecting your hands. So maybe we talk about super glue first and when you might want to use it and when you might not want to use it.
So even the hospitals and stuff might use super glue occasionally to tie up a wound, to maybe less of a scar. And so they've got liquid skin and stuff like that. So if you get a cut, you can put that liquid bandage on there. The reason I didn't put it in the video is because oftentimes as a machinist, we're working around machine coolant and my hands are flexing quite a bit. And if that liquid skin, super glue, cracks at all, then you're just going to allow bacteria and whatever into that wound, and it's going to be likely to get infected. And so I left it off the list because it's just more likely to get infected. And we left it off the list kind of like we left off electric tape and shop rag and duct tape, even though those are probably the most popular bandages used by machinists, right? We've all done that. You grab that whatever rag's around, you wrap your hand, 5 minutes later, you grab a paper towel and some electric tape, and you're good to go. But if you actually want this thing to heal, then you need to put some antibiotic ointment on it, the tribiotic ointment. And I don't even want to mention this, but I just made that video, and on Monday of this week, I was putting my briefcase, my laptop bag, in my trunk, and I had a coffee, and I brought my hatch back down, and I put my laptop down, I moved my coffee, and then I put the hatch half down, and then I headbutted the hatch, and I totally cut open my forehead. I put on some ointment, some Neosporin, some tribiotic ointment, hoping that it would heal faster, right, after we just put out that video. And it's feeling a lot better today. But I really do think it's healing faster because I kept it moist, and it's working out pretty good.
And I think that's one of the other arguments against a reason why you might not want to use super glue if you have the choice is that you can't put antibiotic ointment on and then put super glue over it. That's not going to work very well. So you probably, if you have the choice, you're going to choose to put on the ointment. So then we got talking about gloves, and I think maybe you have most everyone out there knows about the steel thread reinforced gloves that they've got today, but we thought we'd mention it because this is a great way to keep from getting those wounds. There we go. There's one of the kind of sets that we use at the factory.
These things are awesome. So I really didn't use these a whole bunch before I came to work for Haas, and they have them because they handle such big material, and there's some sharp edges and whatever. But these things are just awesome. These are Maxiflex cut TMs, and again, they're not cheap. Maybe $10, but they're awesome. So they're Kevlar reinforced. They've got the rubber coating on them so they're really tactile. You're not going to lose grip on stuff. But what's
And
nice?
there are probably, I don't know, 20 plus models of those. You know, I bought them off their site directly and off of Amazon and probably off of McMaster as well.
Yeah, if you're going to get into a knife fight, this is the glove to wear, right? So they're just amazing. You could be loading stock all day long and not worry about it. My first day on the job, my very first day in a machine shop ever, was loading these toes and heels for golf putters. They were for Odyssey, I think, golf putters. And so they would machine out these stainless toes and heels, and then they would have a third metal in the middle, and you'd screw them all together and then remachine the golf putters. But those things were razor sharp, and I kept cutting my hands on those. So for the first couple of days, I had all these nicks on my hands. And 20, 25 years later, I wish I had been wearing these gloves. It would have really, really saved my hand. There's no reason to suffer. There's no reason to cut yourself in the first place. Find yourself a nice Kevlar glove, and it'll save you.
Cool. All right, well, let's get into, I believe this was a question from the chat last time. Gerard Zonek asks, on an NGC control, how can I set a counter to start counting up from a certain number? And you've done a tip of the day or two about this.
Yeah. So we've got, there's a tip of the day video on M30 counters, and it shows the macro variables involved with those M30 counters. So go on YouTube and Google M30 counters or counters. I guess I could do it right now. And there's some macro variables associated with that M30 counter that shows up here in the bottom right corner of your screen, M30 counter 1 and 2. I think the variables for that are pound 3901 and pound 3902. So you can access those variables, and every time it reaches an M30 in your program, it's going to increment that value by 1. So that's the easiest way to put a counter on something, is just use the counter that's already there. And if this counter now says M30 counter equals 7015, in theory, if I were to go to MDI and type pound 3901 equals 0, and then run that, okay, so that is the right number. Pound 3901 equals 0 resets my M30 counter to 0. And then now it's gonna, every time it reaches an M30, it increments by 1. Every time a part is run, it goes up by 1. We made a whole video on that. And aside from that, you can create your own counter besides the M30 counter on the main page with macro variables. Pound 100 equals pound 100 plus 1. And every time that line of code is read, it adds 1 to the variable that's in pound 100. So there's lots of different ways to approach counters. And they're all macro based typically. There's some other ways I've seen people actually use the tool offset page if you don't have the macro option, which is crazy. People are trying to cheat there. And so what they'll do is they'll use a G10, L20, G10L, whatever, and they'll write to a tool offset. And then every time the tool offset is called up, they'll add something to it. So they're actually storing information in the tool offset page. That gets really complicated. Just get the macro option. Or use your M30 counter with pound 3901. Lots of options. Very thorough.
Yeah, very thorough. Okay, so back to a kind of a basics question. Ward Jamaith asks, can you talk about concrete requirements for a VF2? I only have a 4-inch slab in my shop and would like to not cut up my floor. So back to the questions of compromises, right?
Yeah, especially if it's a rental, right? You're paying rent in this place. You don't want to put money into somebody else's building for them, which is great. I always tell the exact same story when we talk about concrete. I was running a machine, and the machine was a giant. It was 16 leveling pads and 60,000 pounds. And I kept having machine issues where I was trying to hold a 1 thou tolerance over a big part, and I couldn't hold it. At the end of the day, I was running on 6-inch concrete, and the machine manufacturer said I needed this much concrete. So I had to cut out an area around the machine. We came in, and $10,000 later, we had a 3 or 4 foot deep slab of concrete for this one particular specialized machine. Now, that's not typical. Now, a VF2, a TL, these are smaller machines, and you don't need something that thick. It's going to be just fine. If you get to a VF6, a VF12, you've got very specific requirements for concrete. And if you go on the internet right now and you were to look up Haas pre-installation checklist, you'll find what our requirements are for concrete. Again, Haas pre-install or pre-installation checklist, and it's going to tell you what you should have. Now, typically for a VF size machine, we ask for 6 inches of concrete, reinforced, and we tell you what type of concrete, you know, the 3,500 PSI or whatever the requirements are. And if you have certain machines like a EC 1600 or some of our other big machines, we might require you to get like 12 inches of concrete. With that said, I just told you you need 6 inches or 12 inches of concrete. People run VF2s on 4 inches of concrete every day of the year. It's not a problem. Unless you've got slab issues, right? Or you've got a forklift that's driving by on that 4 inches of concrete, you're gonna see a problem. Whenever that forklift drives by on that thin slab, you're gonna have some issues where your machine is gonna twist by as much as your floor is. And so again, if you've got thin concrete, what you might wanna watch out for particularly are the lines in the ground. Can you see this line on the ground here? If you got 6-inch concrete, you're probably fine, reinforced. But if you're running 4-inch concrete slab, don't split the lines. Try and keep your machine all on one slab. If you're splitting the line and you've got a thin slab and somebody's coming by with a forklift, forget it. Those slabs are gonna move and you're gonna be fighting tolerance issues all day long. But again, it's not a problem until it's a problem. But we do recommend 6 inches.
You touched on this, but it has a little bit to do with what kind of tolerance parts you're running, right? If you're running relatively loose stuff, you can get away with more tendency to have some movement, right? I mean, there are people that have machines on their dirt garage floors. Not very many of them, but you know, some people will do these things just to get a machine running. If that's the only place they have it.
Yeah, they'll put up these big, steel plates on a dirt floor, and they'll just drop those down and run the machine.
Certainly not recommended.
That's not our typical install.
All right, so we got a bunch of stuff here in the comments. Thank you guys for joining us this morning. Let's see. Wise Chef asks, good morning. Been wondering what type of tool compensation you guys use and how you use it in conjunction with tool diameter probing. Can you update the wear table instead of a diameter? That's an easy question. It probably doesn't look like an easy question to answer.
Hi. So it's a loaded question for a couple different reasons. Typically, if you're a hand programmer, I program by hand, or if your CAM system spits out compensation by the control, not on the computer or the wear value, you're going to put in a diameter value for your tools. And so when we probe a tool right now, if I probed the diameter of tool 1 and it's a 1/2 inch end mill, it's going to probe and it's going to put in 1/2 inch. But what if my CAM system did all that work for us? And I don't want to probe the diameter as 1/2 inch, I just want to probe the wear value. The end mill comes in as a regrind, it's 0.49 inches instead of 0.5 inches. Is there a way to get the probe to put in minus 10,000ths of an inch instead of 0.490? The short answer is no. You can go in and edit your Renishaw macro variables to compensate for that, and there's different ways to do that, and I've done that before on different machines. But typically, no. Normally, we just allow our CAM system to do all the work for us. We only probe the Z length on our probing system, not the diameter. And then we just enter in we probe the end mill or put it on an optical comparator, whatever, our tool presetter. We know that it's 10,000ths of an inch undersized, and we enter in minus 10,000ths of an inch. It's a good question. It might be good to put in an enhancement request, see if we can add a probing option to probe the wear value instead of the diameter. And I can do it, but it's a little sketchy. You go in and what is it, the 9885? There's a program there, line 30, and you have to have it adjust the macro variable. It's not common. So my short answer is no. You need to probe the full diameter if we're going to probe anything, not the wear, unless you start writing your own custom macro.
Let's see. You know what? I'm going to jump down to another question because it's kind of a little bit along those lines, maybe. Man, I don't even remember where this came from. I think this is the last chat. Robert Hughes asked, would a 4-way boss measure be more accurate than only measuring one side on each axis? We got into talking about when you want to use, a boss measurement versus a rib measurement.
Yeah. So the easiest way to probe on a Haas machine by far is just to go to the offset page and press F3 to measure a boss, or we can go to VPS on the new machine and go to our probing cycles. Work right there. So I can probe a bore, a boss, a rectangle, a web, this type of thing. And so this is probing a bore right here. Now, if it probes a bore, it's going to use a whatever cycle, but our bore or boss probing cycles are always probing 4 points. They're going to probe, if I was going to probe my mouse, and this was a round boss, our bore and boss probing cycles always hit 4 points. So it'll spit out the X and Y center of that bore along with the diameter of that bore. If I was only hitting 2 points, let's say 2 points in the X, we would call that an X web. And that's only going to tell you the X center point and the X distance there. And if we were going to do the same thing in the Y, we've got a Y web that we could do as well. So a bore and a boss cycle are always 4 points, all 4 quadrants. A web is only 2 points in the X or 2 points in the Y. If you can't get all 4 points on a boss because there's a notch on it or something like that, you can go into the Inspection Plus cycles, the G65P whatever cycles, which are shown in the Inspection Plus manual, and they'll show you how to use a 3-point boss measurement, where it can actually pick up a circle using only 3 points, which is great for half circles or circles with notches. But we've really simplified it. You don't have to worry about that a whole lot. We've chosen the best cycle for you and put those into the probing templates on your controls.
Okay, so I guess I'll field this one from the chat here. Prasad Ati asks, Haas recently opened certification program for India. Can you please brief on the upcoming advanced courses? So we've talked about this a little bit. We just opened the Haas Mill Basic Certification for India. We're about to release the Lathe Basic Certification to the US and probably Canada, I guess. Anyway, I'm assuming that that's going to be coming shortly to everywhere else. As we mentioned last time, we just finished up translations for Spanish, German, Italian, and French, and that's for the mill program. We are beginning work on the intermediate program, but that's just in the very early stages, so it's going to be a while. These things take quite a bit of work and time to put together, so that's down the road. But next up, of course, for India and everywhere else that we can put it is the lathe certification, the basic certification. Let's jump over to an email that came into the TLD email. Can we use G68 to rotate a program in the XZ plane as opposed to rotating in the XY plane?
Okay, yeah, so we get emails all the time. We have applications department at Haas. We've got applications engineers all over the world, and these are the type of questions that we get on a daily basis. So this one came into our TOD email address, and the customer was asking how to rotate, but not rotating looking down in the XY position. He had a part that was actually a guitar neck, and the guitar neck is at an angle, and he wanted to probe that angle on the headstock of the guitar and have an end mill come down and run that. So how do you do that? How do you approach that? And not getting too deep into it, yeah, you can do just about anything with the Inspection Plus cycles. And so I set up a test part here, and if you can see this, this was kind of simulating the neck on his guitar. This is at an angle right here. And so what I'll do is I'll come down and I'll probe 2 points. And then we will use that data to use a G68 rotation. And this is how that works. With our probing routines, you can go to your Inspection Plus manual and you can probe anything. We've got a 9811 as a single point probing cycle, beep. If you run a 9811 single point probing cycle, beep, and then you call up our G65 P9834, it's in the Inspection Plus manual, it's going to take that position and kind of store it. Then when you probe a second position, you can call up a G65 P9834 again, and what it's going to do is it's going to take those 2 probe points, whether it's 2 bosses, 2 circles, 2 points, and it's going to do a bunch of calculations and tell you what the angle is between those 2 points, whether that angle's in the XZ axis or the XY axis or the YZ axis, and it'll tell you the angle. So that's what we've done here. We probed 2 points, And then with that, we come in with our G68 rotation, and we call up an R value, and that angle was stored in macro variable 189. We've made a video on G68 rotation, so check that out on the YouTube channel. And what this cycle can do is it can rotate not only in the XY plane, but we rotated for this customer in the XZ plane. And so I would run this for you, but you really can't see it because the door's gonna be closed. But I sent it to a customer in an email. Can you take a picture of this?
Yeah, can you rotate
Yeah. This is other stuff. My desktop's terribly busy. Okay, this is it. So this is it probing the part. A picture of a picture. It's probing the part. That's one hit, and a second hit. If you were looking at the code, it'd be a 9811, then 9834. And I'm not really machining, so I call it a drill. And now we use the G68 rotation, but in the G18 plane. And you can see that the tool follows that funny angle. I didn't program that funny angle. That's a straight X-axis move, a real simple X-axis move. All the rotation was done because of the G68. So you can get crazy with probing. You can do all kinds of very cool things. It's all in the Haas macros here. And if you need help, you can call up the apps guy at your local Haas factory outlet, or watch all of our videos on probing, and we'll get you going. But with custom macros, you can do anything.
Yeah.
I just did that. That's an email. So we get those emails all the time, and it's fun.
Hey, we just crossed 150 subscribers. Thanks everybody for joining us today.
Yeah, thank you guys. As usually have
Connections, I should say.
folks from all over the world signing in here. Next up, let's go with a question from Randall Tutterow. Typically on a live tool lathe, do you have to sweep in every center tool in X and Y? Or if you do one, should they all read the same?
Center line on an XY tool? Or
Sorry. Do you have to sweep in every center tool in X and Y? I guess I'm maybe the center of every tool, probably.
So especially on a live tool lathe, we have one right here, an ST20Y. This machine is unique. This is a BMT turret. The BMT turret is really nice. They're built solid. They've got this block that's got these kind of doweled lines in there. It just locks in.
You want to take a look?
Yeah. We'll stay out of the light here. So you can see that it's got these alignment grooves on there. So everything's pinned. So for these guys, it's not really adjustable. And you're thinking, oh no, it's not adjustable. What if my ream is not perfectly on center in the XY? I don't want that thing walking. Well, here's the beauty about this particular lathe. It's a Y-axis lathe. So what I would do is I would walk over to my toolbox there. I would pull out a coaxial indicator. I would put it in the chuck of the lathe, and I would sweep the holder in the turret, and then I would simply give that ream, in this particular lathe, an X and Y tool offset. So every time that tool is called, it positions perfect. So me personally, if I want it within 1/1000th of an inch, I leave everything at 0 and I run it. If I want it within 1/10 of a thou, within a couple microns, oh yeah, I am indicating each and every tool holder that I put in the turret. And then I'll give on this lathe, because it's a Y-axis lathe, I'll give it an X and a Y tool offset and I'll call it up. Now on our VDI turrets, things are different. We can adjust the X center line. There's an F2 center line. You press F2, it tells you the X center line. But what if that holder is off in the Y-axis as well, and it's not a Y-axis lathe? You can't adjust it with a servo axis. You have to physically adjust that VDI holder. On those lathes, there's a cam. When you pull off the BOT, bolt-on turret holder, there's a little round cam and it's eccentric. You have to twist that little round cam, put an indicator, and say, okay, this holder is off by 1/1000 in the Y-axis. You pull that off, you adjust the rotating cam, you put it back on, you sweep it until things are perfectly on center. So you mechanically adjust things in on a lathe that does not have a Y-axis. If it's got a Y-axis, I don't manually adjust anything. I just give it an XY offset on the tool offset page and run the thing. But I'm pretty picky. I like my drills and everything just perfectly on center. And so I will definitely give everything its own tool offset. And we've got a video called Setting Up Live Tools on the Haas YouTube channel, the Tip of the Day playlist. And we go into that a little more in depth. But we don't show is how to set the XY offset. But it's really simple. You just go there and you just put in the number that you see on the screen and go from there. But yeah, I'll set every tool.
Okay, let's jump over to a question that I think this is from the stream last week as well. Adam Raw, or Rao, I'm not sure how to say the last name, asks, is it possible to have an NG system boot into Safe Run? We just got our machine and would like to keep the training wheels on for a while.
Yeah, so what he's talking about with Safe Run is that if you're in rapid mode, now if you're feeding, but if you're in rapid mode, G0, and the tool collides with something, it hits something when it wasn't expected, the machine can actually stop itself, right, before it does much damage, before it does any damage. You might chip the tool, but it's not going to hurt your machine. Now, the only way you can get into that Safe Run mode right now, if you've got a next-gen control machine, is from memory mode. Oh, it's right there. So from memory mode, it'll activate Safe Run, and I'll press the F3 button. And then now you'll have this watermark that says Safe Run. So the question that's being asked is, can the machine start up in Safe Run mode? I don't think so. I don't know of a way to get the machine to start up in Safe Run mode. You must turn this on after you start. And the reason for this is that not only does it save your machine if it's in G0 and it hits something, it also slows down everything. It slows down all of our rapids to a reasonable rate that the machine can stop itself at. And that's not good if you're running production. So the way that the Safe Run was built is that while you're setting up a machine, you turn Safe Run on, you proof out your program, and then of course after you've run it once, it's going to do the same thing every time, so you can then turn Safe Run off and it'll go full speed and run production. So right now I believe, and somebody will chime in if I'm wrong, I believe the only way to turn on Safe Run mode on a next-gen control is the F3 button from memory mode.
Good one. Okay, next up we have another question via the TOD email. John Gelder asks, just got a new ST30Y up and running. Is there any chance you'll be adding axial live tooling operations to the VPS templates? And I could probably start out by answering that. The answer is yes. Those are coming right down the pike right now. As he said in his email, we already have the radial drilling, tapping, and spot drilling templates in there in the VPS templates, but we are just about to release the axial ones as well. And anything else you want to say about that?
Yeah, the easiest way to get those, so I was talking with Milton. He's one of our product specialists, heavy on the lathe side. And he just sent me those templates. So VPS templates do all kinds of cool things. They just make it really simple to program conversationally from the control on your lathes and mills. And they're adding cycles all the time. And they've done really, really cool things lately on the lathes especially, and they're going to go back to the mills in just a little bit. But they've just gone through all these live tooling axial and radial cycles. And so while you might not see them on your lathe today, you can always have the software upgraded at some point in the future and see what's new. I know they've added in cycles for broaching, kind of like a G76 cycle, but we have a new cycle that's coming in, I think it's G166, that comes in a broaches, right, with a single point tool. And then we have all these other new cycles for drilling and axial moves that are just fill in the blanks, you answer the questions, and it does it for you. If you don't have those yet, you can talk to your HFO. At some point, you might be able to just load in those templates. We've got, when you go to list programs, and you go to, let's see here. So when I go to list programs on an NGC machine, I can go to user data, and then I can go to my VPS or custom, or, this is where all these VPS programs are stored. And so all of these templates are stored right there on the control. You don't really even have to upgrade the software to get these new templates when they're ready. You can, we'll make them available and you can just kind of drop them in on your own. And so we'll look at doing that. But just keep your eyes open, talk to your HFO, see what's out there.
The chat room and the views have stayed super consistent. We've been around 150 all day, so that's been great. Thanks, everybody.
Thank you, guys. Thank you so much.
35 thumbs up. That's good, too.
Maybe I should even ask this. This is a little bit of the, not a way back machine, but Us Renmei asks, can you go over finding center of rotation on a trunnion? I have a 2014 without DWO and would love to have you explain the process better. Not something we're going to do in depth right now. We do have a selection of, what's it called? Simplify 5-axis or?
Don't fear 5-axis.
Don't fear 5-axis. Boy, I should know that by heart. Where one of our apps engineers, John Nelson, walks through all kinds of aspects of setting up your 5-axis on your mill. But yeah, it's something, maybe we would look at that. That's more of a how-to step-by-step thing.
If you've got a rotary, typically let's say you've got what year was that? 2008, 2004? Oh, no DWO. If you've got a typical rotary, most of our, let's say you have a TR210 rotary, and the tilt goes back and forth, and a lot of those go forward and back by 120 degrees, which means it's past 90 degrees. So the platter can go 90 degrees this way and 90 degrees that way, which makes it easy. What you'll just do is you'll grab an indicator, whatever indicator you have. You will take your platter and then you will rotate it 90 degrees. You'll come in and you'll indicate the side of that platter. And you'll write down the machine X position or Y position. Then you'll rotate it 90 degrees the other way. And then you'll come over and you'll indicate that edge. You write down those numbers and you find the mean. You just add them together, divide by 2, and that is the exact center line of that rotary platter. When you've got that distance, if it says that from here to here is 2 inches, then you know that when you go back to normal, that the center line of rotation for the tilt is 2 inches divided by 1. It's 1 inch above my platter. So whether it's here, here, or here, because I've measured it here and at 90 degrees, here, I know exactly what that distance is. You divide that by 2, and then no matter where this thing is, that's how far my center of rotation is. So if from here to here is 2 inches, then half of that is 1 inch. So then I know if I indicate against this edge and move over 1 inch, that's the center of my rotation. From here in the Z, if I were to touch off on top of the platter and then move up 1 inch, that's the exact center of rotation. That's a basic concept. It's really easy if you can go 90 degrees and 90 degrees. If you can't go 90 degrees and 90 degrees, get good at trig, because that's the only way I know how to do it. You'd have to put a spherical ball on the rotary here, indicate it here, indicate it here, indicate it here, find 3 points, trig that out, or draw it up in your CAD system, find the center of rotation. But if you can go plus or minus 90 degrees, it gets really simple.
Cool.
Good
Cool
basic explanation.
Shout out from South Korea.
Yeah. Let's go with Alex Bellringer asks, is there an easy way to probe 6 points on a face and then take the average to your work offset?
Maybe, I don't know. I have to look it up. I could certainly do it and write a macro that does it. You could just come in with a 9811, beep, 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 take all those points, write into a macro variable, and then write the first point to macro variable 100, second one to 101, 102, 103, take all those values, add them together. But that's doing it with a macro variable. There might be a Renishaw cycle that does it all for us automatically, but I haven't used it. And so we'd have to scan through the Renishaw, the Haas Renishaw Inspection Plus manual to see if there's a cycle. I don't know that there is. There might be. But again, go on the Haas website, Google Inspection Plus, grab that manual, download it, and just scan it and see if there is a cycle. If there's not a cycle that picks up a plane with multiple points, then you're going to have to pick up 1 point at a time, take all those data points, add them together, divide by the number of data points to get your average, and then write that to your work offset. You'd have to write your own. But again, I'm not sure if Renishaw has a cycle or not, so download that Inspection Plus manual.
Yeah, I want to second this comment by username. Thank you for answering that question. That was a really great explanation about the Z-axis offset. Amazing explanation. Thank you, Mark.
Thanks, Mark.
Cool.
All right, thank you everyone that's on the stream right now. We've got people here from Belgium, Russia, India, HFO, Denmark, Spain, Korea, Iran, and Finland. So again, across the world it seems. Let's go with another one from, I believe, last week's chat. Lundy Thompson asks, is it possible to do a bar push while running a part on the sub spindle?
Ooh. I wasn't listening because I was on the inspection. Wait. Okay, gotcha. I was looking up the Inspection Plus manual trying to see if there's a cycle for it, but whatever, you understand. Go to the Inspection Plus cycle. You're asking about bar pushes and subspindles?
To do a bar push while running a part on the subspindle. So this, I'm assuming this is simultaneously doing these two things.
Yeah, so I imagine that the reason they'd want to do that, right? Why would you want to do a bar push and machine at the same time? Well, to save cycle time. Why have it, why wait for the little bit of time it takes when you can be doing something else at the same time? I think my short answer is no, you can't. G105 is the G code that commands the bar feeder to do its thing. Now, if you've got the new bar feeder, it's super fast. You're not losing hardly anything. It's click, click, click. If you've got the older bar feeder, it's still pretty fast, but it's going to be click, click, click. You're still a second or two in there, and if you're running thousands of parts, those seconds add up. G105 is a group 9 G code, which means you can't call up any other group 9 G codes on the same line of code. It has to run the G105 by itself, and then finish doing that G105 bar push, and then you go on and do other stuff. So the short answer is, I believe, no, you can't be running other G codes, because chances are if you're doing machining on the subspindle, you're going to be using another G9 or another 09 group G code, and it's going to want to finish this before it moves on and does something else. One line of code at a time. And so there's not a really good way to do that. We can look at adding an enhancement that might work out, but a lot of times when you try doing more than one thing at once, there's conflicts in the code that would cause us problems. So for right now, no, finish the bar push, then do your subspindle machining.
Alrighty, a bunch of more folks in the chat are letting us know that they're also on here from various places. Switzerland, Indianapolis, Ireland, Illinois, and Texas are on board with us here. So thank you guys. So glad that everyone all over the world is joining us. Let's go with another question from Zephyr Old. Hi Mark, I would love to see a tip of the day about how important it is to not recut chips and the best way to prevent that. And we've talked a little bit about this on previous episodes, but
it's a funny thing. You'd think that, so the question was about recutting chips. Now we've got a video, you can look it up. It's on G187 that we made. G187 is a code that adjusts the acceleration, deceleration, smoothness, lots of weird things in order to give you a more precise cut or a smoother cut, whatever you want. And a lot of times when people see defects on their parts, you can fix that with maybe a G187P3. If you're cutting chips, if you're running over a chip and squishing it into your part, your code's not going to fix that unless you just change the way you approach it. So if you're climb cutting means that if this is the edge of my part, climb cutting means the tool is spinning this way and it's climbing this way. And you can tell that if it's climbing this way, the chips are getting spit out behind the tool. Now, conventional milling is where the tool has to spin this way, but we're going backwards. And so you can tell what's happening here is if it's conventional milling going this way, that it's spitting the chips out in front of it, and then it's running right over them. And it's possible that it might run over the same chip. So one way to avoid this is just by climb cutting, which we do a lot of times on CNCs anyhow. But the real solution to not cutting chips is good coolant. So we've got P-Cool on the machine. P-Cool is a knob. P-Cool is this knob here, and it's programmable coolant. You don't want a machine with a probe, but you get the idea. So this guy's gonna come up and down, and you can aim this in the code. Yeah, you can aim that in the code right at the edge of the tool. Right at the edge of the tool. P-Cool, right? We've made tons of videos on P-Cool and this kind of stuff. And what we've got now in the machines is also this coolant ring. So this thing's got coolant from all sides. And the adjustable coolant, if you've got a long tool, you can have the code put the coolant right at the edge of the tool. This is really the best way to keep chips off of the tool, is to just keep lots of coolant flushing it out. I don't think about it much in the code. I just write the program, and then I get the chips out of the way with my coolant. And if you really want to take it a step further, then you get TSC, through spindle coolant. And even if I'm making a short, well, most of these tools have TSC. There's like little holes, you can't see them. Oh, you can, right there. So the coolant comes out of this guy at high pressure, 300 PSI or 1000 PSI, depending on the option. And it's a big squirt gun that keeps right on the edge of the tool, and it comes through the spindle. Coolant comes in, comes out through the little holes, keeps it off the edge of the insert. Trust me, you're not going to be running over chips with the edge of the tool if you've got TSC. So the basic solution is to adjust your coolant nozzles really well for each tool, and that's why we have the P-Cool positions that you see on the offset page.
Hey Mark, what's this guy?
Same thing. So this is unique, and if you're not running coolant, if you're just running dry, this is a MQL. It's an air blast. So we have two systems. We have one that's just an air blast where it shoots a stream of air onto the tool for the exact same reason you were talking about. It's keeping the chips out of the way. If you're machining dry, you're cutting steel, you've got a nice end mill. And this one's a little bit different. It's MQL. It's got a little hose here on the side that comes up and over. And look on the side of the machine.
Yeah, there's a little reservoir, right?
Yeah. So it's got this guy, canola oil or whatever they run in this thing. The MQL. MQL is minimum quantity lubrication. It grabs some of this and it mists it and pushes it through into that air gun. And it keeps the chips from building up in front of the tool that way if you don't want to use flood coolant. So keeping the chips out of the way is a big problem, and we deal with that with TSC, with flood coolant, with P-Cool, programmable coolant, with an air blast. We also have through tool air blast. If you wanted to run dry, instead of using it like a squirt gun with TSC, we run TAB through tool air blast, where it uses air through here to get the chips out of the way. And that's really useful if you're going deep, especially with deep hole drills. You need TSC. If you're going to gun drill at all with the deep tool, you need TSC. If you're cutting some steels, the TAB works fantastic. But we usually fix these problems mechanically, not from the program.
That was a great overview on.
That was like a whole chip clearing video in itself
chip
right
clearing
there.
and tool lubrication in 5 minutes. And as I look up here, Andrew, 216.
Yeah, and people are reminding us that they're from everywhere: Australia, UK, California, Connecticut, Germany, North Carolina, New York, Ukraine, Poland. So thank you guys, Netherlands, India. That's awesome. Let's go to a question. This is back from the.
Real quick. Somebody asked where we are. Where are we, Andrew?
Where are we? We're in. Well, actually, today we're here in our Camarillo warehouse where we have our small set that we shoot a bunch of videos on. Of course, the factory's in Oxnard, right down the road, about 5 miles or something like that. Yeah, sunny California. I guess it's getting sunny everywhere else as well, for the most part. So this is a question from your 4 tips in 1 day tip of the day. Jibe Shrugs says, when is there going to be a probe program to get us close to getting a vice 90 degrees? This is kind of a loaded question, really.
I've got probing on the mind this week. That's all I've been thinking about. Well, other things as well. But so that Inspection Plus 9834 program, what that does is if I probe one thing and then another, it tells me the angle between those two things. Probe a bore, the 9834 tells me the angle between them. There's another cycle in there called 9843, not 9834, but 9843. And in the regular XY plane, it goes beep, beep, and it tells me the angle. But if I've got a vise sitting on the table and I'm trying to make it straight, knowing the angle is not enough. You can probe the angle and then rotate your program with the G68. I made a video on that, so go on the Haas YouTube channel and just look up G68. We'll show you how to do that. But if you don't want to probe the vise that's off and then rotate your program, if you just want to make the vise straight, I don't know how to do that with the probe. That's the one thing I don't ever do with the probe. I come in there with an indicator, normally a regular Interrapid or Brown & Sharp best test indicator, or even this Heimer. You can come in and indicate along the vise, and you'll see the needle move until it's straight. And that's the one thing I still use an indicator for. Everything else I probe, but to make a vise straight, I'm still using an indicator.
It's an iterative process.
Yeah, you want to go back and forth.
You're going back and forth and getting closer and closer.
It's a good question. So if you're a Renishaw probing rep, you can answer, and right now you can comment. I know you've got stuff like the Supra scan, and it's like the OPS 60 or whatever spindle probes, which are scanning head probes, not like the OMP40s that we're using. They're meant for like scanning along an entire surface. Maybe there's a way to do that. So if you want to write a check, maybe you can get a fancy killer probe that can be used like an indicator, but I've never seen that done. Not for that purpose of something like putting up a vise. But it's a great question. I'd like to see what the Renaissance guys have to say about it.
Cool. Okay, we've got it. This is from Backaways in the chat. Arrow Method asks, on the NGC, how do you jog lock and access at a different feed rate than the 4 speeds on the handle jog row? Is that something you can even do?
I don't know. That's a good question.
That's a great question.
So on the buttons on this thing down here, there's 2 numbers, right? There's 0.001 and there's 0.1. And this one says 0.001 and then 1.0, 0.01 and 10.0. Why are there 2 different numbers? The top number is an increment when you're hand jogging. It's how far it's going to move per click. Click, click, click. That moves 1/10 of a thou. The one below it is kind of a feed rate in jog lock. If I were to hand jog and press jog lock and press the button, it's now moving at a jog rate. Can you see this? It says jog rate of 10.0. The reason it's at a jog rate of 10.0 and it's on jog lock, I press jog lock and then the axis, you have to be careful because it's really moving right now. It's at a jog rate of 10 inches per minute because that little number on the bottom of this button said 10.0. So if I was in hand jog mode and we click, it would move 0.01 inches if you're in inch mode. Otherwise, it's going 10 inches a minute in jog lock. This one says 100 inches a minute. So if I press this button, all of a sudden it's going much faster, and this number here on the screen changed to, it's going to alarm out there to travel or stop. Now my jog rate goes to 100. So how do you adjust that? Can I do it at a different speed? I've got no idea other than just adjusting the feed override. So if I want to feed at 50 inches a minute in jog lock, I would set my feed override to 50%. And now I'm going to jog lock. It's going to be moving at the 100-inch increment, and it's going to be, let's see it. Oh yeah, it affects it. And now it's going to be feeding it at 50% of my commanded feed rate. So it's a little wonky, but normally you're not doing any real machining in jog lock other than just cutting some jaws. And so that's how you do it. You just use these lower numbers here, tells you how fast you're going, and then you use the feed overrides if these aren't exactly what you want, like you said.
I love it when the other folks in the chat start helping out and answering questions.
Everyone knows.
Everyone's chiming in. That's great.
So how many Haas users are there? So I'm the luckiest guy in the world. I get to sit here and work on the machines and learn new stuff. But Haas is just the most popular CNC machine like out there, and we realize that the Haas users are better at using the machines than we are most of the time, because they're spending hours and hours and hours each day. So there's such a unique user group of Haas users, and so we get a lot of questions, but we also get a lot of answers from the Haas users and a lot of input on the machines because there's just so many guys who are just experts. There are more experts on Haas machines out there than you could believe, and we understand that.
Yeah, you watch the video for like a basic understanding, and then you go down into the chat.
Oh yeah, exactly.
Yeah, just like in the YouTube videos themselves, the comment section is there's a wealth of information there. Exactly. Jake Abram asks, can G187P1 help my look ahead using Fusion Adaptive Clearing roughing operations?
Yes and no. It's going to look like it helps, but it doesn't. What the G187P1 is going to do, you've got a ton of look ahead on the next gen control, NGC. It sees the code a million miles ahead. If your program is running slower, it's intentional because the acceleration and deceleration of the moves is set in stone. It's going to take a certain amount of time to get up to speed and a certain amount of time to slow down. The G187P1 puts it into roughing mode, which says instead of accelerating slowly, accelerate quickly and then move on, which is going to give you a jerkier motion, but you're going to run faster. So if you're running something like a roughing operation, yeah, I might run a G187P1 and get through that part quickly. But on that finish pass, I'll just call up a regular G187 or just leave the machine the way it is, and that's normal smoothing. Or I might call up a G187P3, and that's going to make it very deliberate. It's going to follow a very exact tool path. It's going to have a very natural, slow acceleration and deceleration, give you in theory, a better part surface depending on your part. And I use it all the time for my finish passes, especially on 3D surfaces.
Guys, have we ever had 250 folks watching?
I don't know, man. That sounds like we're getting up to to record territory there.
Thanks, everybody.
So this is an interesting question from Matt Newman. This is from last week's 2 weeks ago. Is it possible to stick a live tool in a TL turret and run fourth axis jobs?
Where did you get, wait, is that, I wonder if that's the whole question. Where do you get live tooling on your TL? Oh, if you put one on, you could bolt it on yourself.
Yeah, I guess so.
I guess so. So a TL is our tool room lathe. It's our entry level lathe, right? I don't know how much they cost, under 30 grand. And it has certain features and it doesn't have certain features. One thing it does not have, I think, is a brake. So on a normal ST20, it's got a literal brake on there. And if I command an M14 or an M15, it's gonna, like the brakes on your car, clunk, clunk, and it's gonna lock that spindle in place. And it's gonna hold it in place while I can do some machining on the face, right? If I have a live tool that wants to come in and drill, locks it in. If it didn't have that brake, you can use the electricity going to the servo motors to hold it in place without a real brake, and it's going to hold it in place with an M19. It's not quite as accurate as the real brake. It might move on you if you're pushing it, but you could use an M19, orient it, and come in and drill. Now, if you don't want to just drill on that spindle, let's say axial drill or radial drill in a single point, let's say you wanted to mill a hex, you can't do that on a TL because it doesn't have a true C-axis. On this lathe, it's a C-axis lathe, and around the lathe spindle motor, all these geared teeth, like the flex plate or flywheel on a car, all these geared teeth. And then we've got a gear on a servo motor that engages with that, and it controls the rotation perfectly and keeps it in line with the live tooling. A TL doesn't have that. And so you really have to buy a live tool lathe or a C-axis lathe that can rotate while the tool is moving if you want that kind of motion. You could, I imagine, grab a live tool, whatever, a drill motor, bolt it on the turret, move this thing and orient it with a M19 and drill axially. It's not going to move. If I was going to go this way, I don't know if I'd trust it too much, especially not off center. If you were off center without a brake, you'd be fighting that spindle and it would fight you back. It doesn't like being pushed when it's using the spindle electricity to hold it in place with an M19. If you were going to drill off center radially, you need a brake to hold it in place. So the short answer is no. The long answer is sure if you're just drilling a hole on the face.
Great answer.
Alrighty, last week or 2 weeks ago, we also had a question from Sick Trick and Tuner. It's hard to say. Looking at buying a TM3P, what spindle is a better option, the grease packed or the regular one? Why would you want one over the other? And the answer is pretty simple. You're going to get a grease packed spindle if you're machining something that you can't get oil on. Phenolics, wood, stuff like that. And that's pretty much the only time you're gonna get that. I think that most shops are gonna want a spindle that's oil lubricated, continuous air oil mist, which is how our regular 40 taper spindles are lubricated. Nothing wrong with the grease pack, but if you're not machining something that you can't get oil on, then typically you're gonna go with an oil lubricated spindle. Pretty basic. I don't think is there anything else to add to that? Okay. Alrighty. Let's see. Sorry. This might turn into a long one, but from India, Kanu Goda asked, please make a practical video regarding G44 tool length compensation. Thought maybe we could talk about G44 versus G43.
We're gonna make this video right now. Here's my entire video on G44. Don't use it. Stop, just stop. There is no good reason for you to use G44 other than to confuse the machinist that comes after you and crash the machine. There might be. There are always reasons that somebody might need to use a G44. What a G43 does is usually you'll use a G43H value. If I'm using tool 1, my program will say G43H1. And we know what the H1 means. That means use tool offset 1 for my offset page. But what does the G43 mean? The G43 just means add my tool offset to my work offset to get my position. A G44 would say the exact opposite. It would say subtract my tool length offset from my work offset, and that's my position. So you have to change the entire way you think about work offsets and tool offsets, and I've never used it. In all my years, I've never found a reason that I couldn't do what I wanted to do with a G43. So if you're doing something very specific, you might want to set up your tool and work offsets using a negative work offset that way. I don't mean that we're using a positive or negative work offset. If you touch off by hand, your work offsets are gonna, with the tool offset measure button, your tool offsets are gonna be negative. If you use a probe, they're always gonna be positive. That's a little bit different. The G43 is saying add my tool offset to my work offset. The G44 is saying subtract. Weird things happen. So I don't even need to go into it just because I just don't see a reason to use it. But if there's a legitimate reason that somebody out there is actually using a G44, comment or send us an email at tod@haascnc.com, because I don't know of a good reason to use G44.
Wow. Cool. Okay, so we got this one in here in the chat. Bavar Kumavat asks, hey, I've seen other machines while tapping, they dwell at the bottom of the thread. Does Haas have such an option? And then later on he goes on to say that he's had trouble with breaking taps, it looks like, and that perhaps he thinks that dwelling it down there at the bottom of the hole is going to help that.
No. So our G84 cycle does not have a p-value on it that works. I don't think so. We can look it up in the manual and see if there's a p-value dwell that can be used on the G84. I've never done that. What we do have is a J value, which is the retract speed. And if you're having problems with taps breaking or something like that, yeah, sure. I might put a J value on there and put a J1, which means retract at the same speed that I went in at. And that might help things out in your situation. I think the default value is 4, which means we tap in it at 1 inch a minute and we pull out at 4 inches a minute. Because on the way out, all the cutting's done. There's no reason not to get out of there fast. Generally speaking, if you're breaking taps, that's not the problem. There's something else going on there. Take a look at our tapping video. We've got a video on that. We have a tapping faster video, which was one of the first videos we ever did for the tip of the day. And that explains those J retract values and the settings, the setting 44 that goes with it. So take a look at that. But if you're breaking taps, right off the bat, first thing, check your F value, your feed rate and your S value. Now we've got videos on how to calculate feeds and speeds for your taps. So make sure that your feeds and your speeds match for the tap that you're using. Aside from that, make sure that your coolant concentration is not low. If you've got 4% coolant and you're breaking taps, I can tell you that the reason you're breaking taps is because you're running at 4% coolant concentration. Bump that sucker up to 8% coolant concentration, and chances are your problems are going to go away. If you're still breaking taps, watch the tapping video. You might be using a plug tap instead of a spiral point tap or some other thing that we've just simply chosen the wrong tap. So I wouldn't look for a dwell. I would look at all the common causes of tapping issues first before I moved on to something else.
Good one. All right, I wrote it down here. I can't find it in the chat now, but Mayan Mario asks, would you recommend to leave the whips probe in the tool changer all the time versus like pulling it out, I guess, when you're not using it?
Good question. Sure.
Absolutely. I always leave my probe in the spindle in the machine all the time. There's no reason to take it out. The only reason I would ever take that spindle probe out of the machine is if I got stuck and I only have 25 positions and my part has 25 tools and I need an extra spot, I might pull it out and use that spot for something else and then put it back in. Which is, if you're going to do that, you can even leave your same tool offset in there for tool 25, and when you replace it with a different tool, go to your pocket tool table and enter tool 100 in its place. So then when you go and change 100 back to 25, it keeps the same offset. But that's a different topic. No, there's no reason to ever pull your spindle probe out of your machine. And I mentioned this in a recent tip of the day video, the 4-in-1 tips. It was just a couple months ago. When you pull that probe in and out of the machine, make sure you pull it out and put it back in the same way you pulled it out. Otherwise, you might mess up the calibration. And if you don't want to ever have to think about that, then when you calibrate it, when you put the probe in the first place, just make sure that you've got it, as it spins around, make sure that it's got 0 runout. If you take a 10th indicator or a 1 micron indicator while you're spinning that probe and you adjust the little set screws until that ruby tip has 0 runout, then it's not going to matter which way you pull it in and out. But if it has a lot of runout on that probe, oh yeah, you better put it back into the spindle at the same M19 spindle orientation that you took it out. Otherwise, you're going to goof up your probe calibration. But again, none of that matters if you've done your job and you've indicated that probe tip perfectly at 0 when you put it in. But yeah, leave it in the machine.
So we're at practically an hour into this, and we're at 270 people on the stream here. Thank you so much, you guys. We're just about to wrap this up. I don't think I even asked you about this, so this is gonna be a fun curveball maybe. But last time, Aggie 170HSS asked, "What are you currently trying to learn that you don't already know?" Maybe this could be in any walk of life, perhaps.
Okay, so my mind is distracted all the time. It's all I've thought about for the last 2 weeks. 2 different things. One of them has to do with coolant, and the other one has to do with live streaming for 2 different reasons. Because of the issue with the stay-at-home stuff and everything, we've all been doing a lot of live streaming. So me personally, for different venues, and even here at work, I've been looking at all the different ways to get video feeds in and out of a laptop and this kind of stuff. So I'm really locked into that, all the different types of ways of using live stream software for that. Now that's more of a personal thing. A work thing, I've been looking at coolants. One reason I've been looking at coolants is because I've got a UMC over here behind us that sits. This is such a shame. This is gonna be I don't want to even say this.
Don't admit it.
I don't want to admit this. It sits most of the time. And so that machine sits most of the time, and I've been doing some 5-axis work on that lately, and I stole some coolant from the other machine, and I ran out of my coolant, and here in this facility I run full synthetic. And so I added water, and then my pH went low, and long story short, I've got fungus in that machine. I've got some bacterial growth. And so I've been spending a lot of time talking with guys about that, and what do you do about it, and that kind of stuff. Now, if you've done what you need to with your coolant, and everything's correct, your coolant concentration's right, your pH is right, all that kind of stuff, you're using the right water, you shouldn't have that problem. I've been really bad on that machine, and we've got a real bad fungus problem. So I've been looking at what you might do to that. You can add fungicides, you can use biocides, this kind of stuff. But I think what I'm going to do on that machine is actually drain it, run through some cleaner, trim, master chemicals, sell some WAM-X, stuff like that. We can actually pump it through the system, make sure it's all clean, and then I might just recharge that entire system and start from scratch. But so fungus in my coolant is one thing I've been thinking about a lot lately. If you've got a good answer, if you're a coolant guy, give me some answers here, because I'm really good at pushing the buttons, but on stuff like that, I usually leave it to the experts, and I just pick up the phone and I talk to the coolant guys for anything that has to do with that. But I've been thinking about that lately.
Great questions.
All right. Thank you, everyone, for joining us. I think we're going to wrap it up now. We've been just over an hour. Thank you, everyone, for joining us again. At 280 people on the stream right now. Thanks very much. We'll see you again in 2 weeks.
You guys are great chat.
Thanks, guys. Take care. A couple weeks. We'll see you.
Thank you, Mark. See you in a few weeks. Tune in next time, everybody. Appreciate you.